Hi, this is Kumar from Juniper Networks testing team. Today I am going to show you how to configure rewrite rule in EX4300 and how to verify the same. A rewrite rule sets the appropriate cost bits in the outgoing packet, and it allows the next downstream device to classify the packet into appropriate service group. Rewriting or marking outbounding packet is useful when the switch is at the border of the network and must alter the cost values to meet the policies of the targeted peer. There are two types of rewrite rules. So one is the default rewrite rule, another one is the custom rewrite rule. So I'm going to show you both how to configure and how to verify. The first one is the default rewrite rule. When the cost values of a packet match the forwarding class and the PLP values, the switch rewrites the markings on the packet based on the default rewrite table. I'm going to show you what are the default rewrite table available in EX4300. Before that, this is my demo setup. In this setup, I have a two ports which is connected to EX4300 switch. So I have a ingress port by name GE-000. Similarly, I have a egress port that is GE001. So both ports are connected with the traffic generator. Now I am going to log into the box. So what I done is I already added my two ports, 0 port and one first port in VLAN 10. So now these ports become as a L2 interface. Now I am going to see what is the default class of service configuration applied on these two interfaces. So these two interfaces shows only the default classifier information. So by default in EX4300 it will not apply the default rewrite rules. So we need to apply it manually. So I am going to show you what is the default available rewrite rules. Show class of service. So we are able to see there are four types of default rewrite rules available. So first one is for DSCP core points, second one is for DSCP IPv6 core points, and third one is for IEEE 802.1p, that is for L2 traffic, and the fourth one is for INET precedent core points. So by default these forwarding classes are mapped to the certain core points, which means if I am getting a frame uh, which is mapped to the forwarding class, any of these forwarding class, then the frame cost value will be rewritten as per the score points. First I'm going to show you how our L2 rewrite default rule works. So for that, first we need to apply the L2 default rewrite rule to the specific L2 egress interface. Now I'm going to apply the default rewrite tool to the egress interface GE001 as follows. Set class of service interface unit 0 rewrite rules. So default rule. So once you apply the default rule, we can verify the default rule on the interface as follows. Show class of service interface. Now we can see the object name called rewrite output. So the type is IEEE 802.1p. Default rewrite rule is applied. So I'm just going to cross check what is my default rewrite rule says. So class of service rewrite rule name. Fine. So if the frame falls into best effort queue, then if it is PLP low, then it has the code point 000. Similarly for high it is 001. So similarly for EFQA and assured forward and network queue have the different code points. So what I'm going to do, I'm going to check my default rewrite rule properly applied on the interface at the PFE level. For that, I'm going to log into PFE. So in the PFE, show cause rewrite. So it will show you the IDs for the default rewrite rule types. Show IFL bindings. Sorry, show IFL brief. So this output shows the index number for the interfaces. So my egress interface index number is 554. So I am going to see which cause rewrite rule is binded to this interface as follows. So rewrite bindings. So we can see rewrite ID 34 is binded to IFL 554. So 34 is nothing but my IEEE 802.1, that is default L2 rewrite rule is applied to my egress interface. So this is the way we can verify the applied rewrite rule on the specific interfaces. Show class of service interface G001. Okay, so I will going to see show what is my egress rewrite rule says. Show class of service rewrite name. So now what I'm going to do is I'm going to define one classifier which classify the incoming traffic to expected forwarding queue for my code point 000. To verify the rewrite, first I'm going to define a classifier. Classifiers type C1 forwarding class, say expected forwarding, class priority low, then code point C000. Apply. Show class of service classifier. Sorry. Now I am going to apply this classifier to my ingress interface as follows. Set class of service interface G unit 0 classifiers. Now I applied my custom classifier to my ingress interface. So my classifier says if it receives the incoming L2 traffic with code point 0, it will forward the traffic to the expected forwarding queue with PLP low. Now what I'm expecting is, as per my rewrite rule, if I'm getting a traffic on expected forwarding queue with PAP low, then my code point should be rewritten as 010. So we are going to verify that now. So I'm going to send a traffic to this interface, ingress interface first. First, let me clear the interface statistics. So what we need to do is, we need to capture the packets at the egress interface so that we can verify the cost values. Now I'm going to send the L2 traffic to my ingress interface. with VLAN priority as 0. You can see my L2 string. Fine. So see, my VLAN priority value is 0, my VLAN ID is 10. Now this traffic should be classified into expected forwarding queue that I am going to verify now. Show interface queue. My egress interface name is 001. See, I received the frames in expected forwarding queue. Now, if I captured this frame. Now I am going to verify it should rewritten as per my default L2 rewrite. Okay, so I'm expecting my code point 000 should be rewritten for expected forwarding last priority low to 010 as 010. So I'm going to see my captured packets. Where is my captured packets? Here it is. I'm just going to stop the capture. I'm going to save the captured packets in the box. And I'm going to open the captured packets information. So the cost values is rewritten as 010, so which is expected one. So this is the way we can verify the L2 rewrite rule by applying the default rewrite rule, and we can capture the egress packets and we can verify the calls fields. Now I am going to show you how the custom rewrite L2 rule will works. Okay, before going to custom, so we will quickly finish how the DSCP and DSCP IPv6 rewrite rule works, default rewrite rule works. So for that I am just going to make my interface as a L3 interface. I'm making set interface 000. First I am making my interface as IPv4 L3 interface. Show class of service interface 000. Delete the existing custom configuration, class of service configuration. Now I am going to verify show class of service interface. Okay, so it has DHCP default classifier. So we can see that it doesn't have a default rewrite rule applied by default. So we need to apply it manually. So I'm going to apply the same class of service interface 1 unit 0 rewrite rule default. So now I applied the default rewrite rule. I'm going to verify the same. Show class of service interface C001. Now I am going to see my default rewrite rule DSCP type which is applied on the egress interface. So I'm going to see what my default rewrite rule mapping says. Show class of service rewrite type, or I can say name DSCP default. Fine. So now I'm going to see some mapping. So what this time what I'm going to do is I'm just going to check the assured forwarding with PLP loop. For example, for that I need to define one custom classifier, set class of service, classifiers, type, sorry, DSCP, uh, say say E1, forwarding class, assured forwarding, last priority low, say example code point says 000. Commit. So I made a custom classifier. I'm going to apply the same at the ingress interface. Set class of service interface 0000 unit 0 classifiers TCP. Okay, now the custom DSCP classifier is applied at the ingress interface. I'm going to check the same. Fine. So I'm going to check my egress interface which has the default DSCP classifier which is ready. So show class of service classifiers. So as per my classifier, incoming L3 traffic code point 000 will fall into assured forwarding queue. So as per my rewrite rule, once it is falls into assured forwarding queue, then it should rewritten as, let me show like this, show class of service, rewrite rules name DSCP default. Okay, so if it is assured forwarding queue, then the code points will be rewritten as 001010. So we are going to check that now. Before that, let me confirm that my DSCP default rewrite rule is applied on L3 interface at PFE level. To verify that, set VTY 0, show cause rewrite. Okay, show IFL brief. What is my egress interface index number is 554. Show cause rewrite bindings. Fine. So now we can see that rewrite ID 31 which has the IFL value 554 in the direction of the egress. So the rewrite ID 31 is nothing but my default DSCP rewrite rule. So now I verified that my default rewrite rule is binded on my egress interface properly. Now I am going to verify the rewrite rule with the traffic. So let me clear my interface statistics first. Clear interface statistics. Now I am going to send my L3 traffic stream with the diffser code point as 000. Okay, I received 100 out of 100 frames. I'm going to see my egress queue. It should be assured forwarding egress interface. Okay, see, I received all my frames in assured forwarding. Okay, I forgot to capture the packet, so let me enable the capture. Once again, I'm going to send the same traffic. Now let me save my captured packets. Now if I open my captured packet, it should have the value, cost value should be rewritten. Let's go to check the DSCP value. See, that is 001010. So as per my default classifier, the value is the same. So my default rewrite rule says rewrite rule name DSCP hyphen default says assured forwarding queue last priority row is 001010. So which is the same what we captured here. See, that's it. So this is the way we can verify the L3 traffic default rewrite rule. Fine. Now I'm going to show, similarly we can do the same for the DSCP IPv6 traffic. Now I'm going to show you how the custom classifier works. Sorry, our custom rewrite rule works here. Now I'm going to make a custom rewrite rule for L3 traffic first. Before that, I just want to show you the definition here. So we can create the custom rewrite rule for L2, L3 traffic. Sorry. L2, L3, IPv4 and IPv6 iNet traffic, and apply this. We can apply the same for L2, L3, IRB, lag or L3 subinterfaces. So we can configure cost rewrite rule, and we can create the rule by giving a name and associating to the forwarding class and last priority and the code point. So once we create the rewrite table, and you can enable the rewrite rule on the specific interface. So I am going to show you how to create a custom rewrite rule for L3 traffic first. Set subservice. Let it be set. Say R5 say same assured forwarding class last priority low. I'm going to set my code point. Yes. Now I'm going to apply my custom rewrite rule to my egress interface. Show cost. Display set match. I'm just deleting my default rewrite rule which is applied earlier, and I'm going to apply my custom rewrite rule to my egress interface. Rewrite rules DCP R5. Now I'm going to verify my custom rewrite rule is applied properly on my egress interface at the PFE level. For CLI level, I'm going to see. So the index number is 4025. Going to PFE level. So you can see our default custom rewrite rule is created with the same ID 40259. I am going to see show IFL brief. So my egress interface index number is 554. I'm going to see my bindings now. Fine. So under the review rewrite ID of 40259, we are able to see the 554 which is applied in the egress direction. So my custom rewrite rule is applied properly on my egress interface. Now I'm going to check with the traffic interface statistics all. So I'm going to send code points of with all zeros. Let me open my Spirant traffic generator. So I start my capture. So we can see all my traffic is received. I'm just going to check my box now. It should fall in all my packets into assured forwarding queue at the egress show interface queue. Yes, so all my packets now in the assured forwarding queue. Now as per my custom rewrite rule, it should return the code points instead of 0002 all ones. Let me check that. I will capture. Let me see my captured packets. Let me save that first. 218. Okay. See, all ones now. So my rewrite rule, custom rewrite rule properly was for L3 traffic. So similarly, I'm going to make one L2 custom rewrite rule and I'm going to show you. So for that, let me make my interface for L2 first from okay. Let me create L2 interface. Now I created a 2 L2 interface under VLAN 10. Now I'm going to make a custom rewrite rule, set class of service, rewrite rule, just for L2 traffic IEEE, just give a rewrite rule name say R1. So forwarding class, I'm going to give, instead of assured forwarding, give anything. So expected forwarding, say last priority low, code point. Sorry, this is a L2 code point, so it should have only 3 values. So I will just make it 110. So show sorry rewrite rule. Now I'm going to apply this rewrite rule to my egress L2 interface first. Set class of service interface G0 R1. Now I'm going to create one custom classifier for this expected forwarding queue. Set class of service classifiers C1 forwarding class expected forwarding queue last priority low, say code points all zeros. So let me apply this custom classifier to my ingress interface. So now I applied my custom classifier at ingress interface and I applied my custom rewrite rule at egress interface. So this is my egress interface. So we can see my custom rewrite rule R1 is applied. I'm going to check the same at the PFE level as follows. VTY FPC0. Here we can see my ID is some 40000. Now we can see my egress interface IFL ID 554, which is under the rewrite ID of 40000. That is nothing but my default, sorry, my custom rewrite rule. So this is the way we can confirm that your custom rewrite rule applied properly on the egress interface. Now we are going to check with the traffic now. Let me start the traffic. I will clear the interface statistics first. Clear interface statistics on. Let me go to traffic part. Okay, now I'm going to start my L2 traffic. Also, I'm going to capture my frames at the egress port. Start my L2 traffic. Start. So now my packet, so we can see that my packet falls into expected forwarding queue of the egress port. Let me see the captured values. Stop. It should be 110. See, my egress frames properly rewritten as per my custom L2 rewrite rule. So that is 110. Custom rewrite rule versus it says 110. So this is the way we can verify the custom rewrite rule in EX4300. Thanks for watching my video. Have a good day.